All right, hello. Welcome to review of Chapter 6, Part 1 here. I'm just going to doing a bunch of review questions with you, getting ready for the Chapter 6 test. Strongly encourage you to try these first in your notebook before watching the solutions. So the first thing we did in this chapter was exponent rules. So here's a couple for you to try. And just a hint, if you forget how to do them, try to do expanded form, right? Because there's a lot of rules to remember here. And if you can't remember, do expanded form. The only exception to that is negative exponents you can't really expand. So anyways, give it a shot and then watch the solutions. Okay, so on this first one, the 3 gets distributed to both the 5 and the x. But again, if I can't remember that, all I got to know is that little 3 means I have this thing, this fraction, 3 times. Okay, and then once I get there, my numerator is just 5 times 5 times 5. My denominator is x times x times x, which is x cubed. And again, the idea is it technically gets distributed in. But if you can't remember that, expand it out and go from there. Okay, so with a negative exponent, I definitely would flip it. Okay, so on this one, flip it and make it positive. So we'll have the x squared will be on top now, and then we'll have, let's see, y squared and x cubed on the bottom. Okay, and again, this is going to distribute in, but what I would be tempted to do here next is cancel out these x's. So like, basically you have x squared on top, x cubed on the bottom, and those will cancel out. Like if you pair them up, they'll cancel like that. Okay, so this thing cleans up to be just a 1 left on top, a y squared, and then 1x remaining on the bottom. Okay, and now that you're here, now I would distribute this 3 into all the parts. So we have 1 cubed over y squared cubed, and then x cubed. Okay, and then the final rule here is this is power of a power. And again, if you forgot that, just think that little cube on the outside means you have three parentheses, and in each parenthesis you have y, 2 y's, that's y squared. So you have y to the 6th in the bottom there. Okay, so 1 cubed is 1, then we have y to the 6th and x cubed in the bottom. That's our final answer. Okay, another exponent rules one. Pause the video, give this a shot. Okay, so the rules here are you subtract, you do like 7 minus -1 and -5 minus -2. But that gets a little goofy, especially where like you get y to the -7, and does that go in the top or in the bottom? Right, so what I'm going to actually do here instead is I'm just going to flip the -1. So I'm going to bring up x -1 and y5 down. Okay, so we have the x7 and it's joined by an x1 there. And then in the bottom we have y squared, and that's being joined by a y to the 5th. So just flip the -1s. And then from here up top, we add those together. We have 8 total x's. Let's add them down here, and we have 7 total y's there. Okay, and again, if you can't remember that you're supposed to add there, my hint would just be to think of it as like y squared is that, y to the 5th is that. So all total, that's 7 y's. Right? And that, the rule is add, but if you can't remember it, try expanding it out. Okay, just keep going with these exponent rules. Pause the video, give it a shot. All right, so my thought here is this -2 is going to move, and it's going to move everything down, right? Because of the parentheses, this -2 applies to all of that. So there's only really 1 left on the top. Okay, and then down in the bottom now we have 2xy cubed, and that is now to the +2 power. Okay, so our numerator is likely just going to be a 1 here. And then our denominator at this point, again, you could expand this out, but really it just is going to distribute in that 2 on the outside. So the first part, we're not doing anything with, but then 2 squared is 4, and then x squared. And then here again, that's that power rule, so that's y to the 6. You multiply them there. Okay, and now we can just take the bottom and do 4 times 4 is 16. And then x3 and x2, those add to x5. and then y2 and y6 is y to the 8th. And again, I'm not expanding it there because hopefully we're getting good at those rules, but if needed, you can always expand those positive exponents out and figure out how many you got. Okay, again, pause the video and give this one a shot. More exponent rules. All right, so here, again, I would start with this distribute piece. So this 3 applies to everything inside of here. So we'd have 2 to the 3rd, x to the 3rd. And then this is power of a power, so that becomes y to the 6th. Okay, next up, there's a lot of routes you could go here, but I guess 2 cubed is 8. And then we can combine our x's here. So we have x to the 3rd, x to the 1st, that becomes x to the 4th, y to the 6th, and y to the 5th, that becomes y to the 11th. And then we still have this 3 right there. Okay, and then the final piece would be these 8 and 3 you can multiply together to get 24. So we have a 24, x to the 4th, y to the 11th. Okay, a couple more exponent rules, I think. Oh, no, one more, actually. So last exponent rule is one. Pause the video and give this a shot. Okay, so our solution here is 12 and negative 3. Those are just regular numbers. So we can just divide them and get negative 4. And it doesn't really matter if you put the negative in the bottom or the top. Kind of the convention would put it in the top. Okay, and then for the x's, again, I guess the way I just think of it is there's 3 more x's on the bottom than on the top. If we expand it out, x3 and x6, and cancel them out, you have 3 more x's on the bottom. So we're going to have an x cubed here. And then the y, similarly, there's 2 more, but they're on the top. So we'd have a y squared up top. Okay, and then from here, this times 1 really doesn't do anything. So I'm just going to write this a little bit neater and without the times 1. So, whoops, that should have been a 3. Okay, so just writing it in a little bit nicer form, it looks like that. Okay, so we're going to switch gears next and basically converting. So we did exponent rules, but then we started to do fraction exponents. All right, and they are equivalent to radicals. Like this chapter is kind of about 2 pieces, exponents and then the radicals. And then here is to convert. So pause the video and see if you can remember how to convert this one. Okay, so the rule here is the top number is the power, like power lines, and the bottom number is the root, like tree roots. So when we convert this to a root, we would have a power of 7 and a root of 2. Okay, and then the only thing that we're going to change here is that 2 is the default root. So if it's a 2, they usually don't write it. The default is a square root. So if it's a 2, they usually don't write it. Okay, which makes our answer look like that. Okay, one more convert one, slightly different style. Pause the video. Okay, so the trick here is you have 2 bases. You have x to the 3rd, but that 3 is just for x. So the 11, its exponent is like an invisible 1. Okay, so when we convert this to a fraction, we're going to have 11 to a fraction power times x to a fraction power. Okay, and the fraction for 11 is power of 1 and root of 4. So it's going to be to the 1/4 power. Again, the power goes on top and the root goes on bottom. Okay, so for x, it's a power of 3 and a root of 4. All right, and that would be our answer. So it should look like that one. See if I can circle it a little bit better. Okay, next up is just to apply fraction exponents to our exponent rules. So pause the video and give this one a shot. Okay, so to answer this one, I'm going to actually do a simpler one. So if we have like x to the 5th over x squared, you minus the exponents. Okay, and so this is just helping me figure out that what I got to do with this 1/6 and the 2/3 is subtract them. All right, because you go like that and then they cancel out, so you end up with x cubed and you just subtract them. Okay, so our answer to this is going to be x to the 2/3 minus 1/6. Okay, and then all you got to do is make these denominators match in order to subtract them. So we'll take this first fraction times 2, so that we have 4/6 minus 1/6. Subtract those, and that's 3/6 or 1/2. Okay, so our answer here is just x to the 1/2 power. Okay, and then, oh, it looks like their answers are back in root form. So if we convert it, that would be a root of 2 and a power of 1. And those are kind of the default, so they normally don't write them. So it's just going to be that as our answer. It's just square root of it. All right, that's all I got for part 1. Tomorrow we'll have another video reviewing stuff. So thank you for watching.